Greetings everyone. So in this video we are going to discuss about ethers. Ethers are basically again the part of this class of oxygen where we have one oxygen which is bond to two alkyl groups. This is ether. Now if you just look into the history, it was first obtained by the distillation of H2SO4 with ethanol, H2SO4 with ethanol, and distillation of H2SO4 with uh, ethanol, right? So basically when it comes to ethers are very important class because they are responsible for acting as a solvent because they are inert, they are unreactive, and because of their unreactivity we use them as a solvent. And lower ethers are also used as anesthesia in anesthesia. One of the most common solvent which is used as an ether is diethyl ether. Diethyl ether, which is used as a solvent for various reactions such as Wurtz-Fittig reaction, which we did last time, and preparation of Grignard's reagent. And when it comes to anesthesia, we have a lot of anesthesia, ether anesthesia, which are used for making the patient numb during surgical procedures. So, if we just look into the structure of ether, ether is again having a band structure, a tetrahedral band structure, but this time it is having a bond angle which is greater than alcohol and phenol as well as water, which is 110.5. So we can say that the greatest bond angle is found in ether. Now why is the bond angle greatest in ether? Because the repulsion between the alkyl groups is greatest, due to which the bond angle is greatest in ether. Ether greater than phenol, greater than alcohol, greater than water. This is a bond angle which is 110.5, greater than 109, greater than 108.5, greater than 104. That's about it. Now let's just understand a few classifications of ether. Ether are broadly classified into two major classes, which is the symmetrical ether and unsymmetrical ether. Symmetrical ether is the one in which both ends of the ether are identical. For example, on one side there is benzene, another side there is a benzene ring, so it is diphenyl ether. On one side there is methyl group, on the other side there is methyl group. This is dimethyl ether, which is a symmetrical ether. While there are unsymmetrical ether as well. For example, on one side there is an ethyl, and other side there is methyl, so it is unsymmetrical ether. And likewise, one side on there is benzene, and on the other side there is methyl, due to which it is an unsymmetrical ether. All right. And when it comes to its structure, again, oxygen is having sp3 hybridized orbital which bonds with either an sp2 hybridized orbital in a phenyl ring or sp3 hybridized orbital of carbon in an alkyl ring. So this is about it. Now let's just move on to its physical properties. Number one thing which we need to consider is the lower ethers. Ethers generally exist in the form of liquids, high volatile. They exist in the form of high volatile, flammable, low boiling point, low boiling point liquids. Now there are some exceptions as well. Exception is number one, there is there is dimethyl ether, dimethyl ether, and ethyl methyl ether. Both of them are used. Both of them exist in gaseous form. Because of the small lower molecular mass, they exist in gaseous form. These are it. gases, right? And when it comes to ether, they are very unreactive. Let's just discuss it in second point that uh, ethers are having a very weak hydrogen bonding. Generally, do not form hydrogen bonding with their own molecules. For example, if it is one ether molecule, it does not form hydrogen bonding with another ether molecule. If I were supposed to make a hydrogen bonding here, it would not be correct. It is not supposed to make a hydrogen bonding. No hydrogen bonding made, but it can make hydrogen bonding a very weak hydrogen bonding with water. For example, if I just dissolve ether and water, then it is going to make a very weak hydrogen bonding. That is the reason it is slightly soluble in water, slightly soluble in water, but it is completely soluble, completely soluble, completely soluble in organic solvents. Organic solvents. Right. So this is an important thing. Now, when it comes to its reactivity, if you just talk about how reactive ether is, so ether is generally it is very unreactive. It is unreactive, and because of its unreactivity, ether is unreactive, and because of its unreactivity, we basically call this we basically use ether for a lot of different purposes like solvent, and we use lower ethers for anesthesia. Why? Because these are very unreactive. So this is an important thing, and alongside that they are anesthetic. Now let's just move on to another part, which is its preparation. Ether can be prepared in three major ways. Number one way is the dehydration of alcohol. We have studied that dehydration of alcohol produces alkene. But whenever we are going to perform dehydration of alcohol in the excess of alcohol at a lower temperature of 140 centigrade and concentrated sulfuric acid catalyst, then we are going to get a diethyl ether instead of alkene. Now the reaction mechanism of ether is pretty simple. It only includes two steps. There are two steps involved in the reaction mechanism of ether. Number one step is the formation of oxonium ion. Oxonium ion. It is a general reaction mechanism for all types of reactions. Formation of oxonium ion. And number two step is attack of nucleophile on electrophilic carbon. Let's just look into it. For example, if I just take, let's say if I take this. Oops. Let's say if I take, we choose a new color. Let's say if I take this, right? This is the OH, right? This is OH. And now what I'm going to do is, what actually will happen is, the oxygen, a proton, because we are using a dehydrating agent, a proton will come. The proton is obtained from the dehydrating agent. So a proton will come. This is a mechanism for, let me just write it. So this is mechanism for dehydration. It is a mechanism for dehydration. When the H2SO4 is high, when the H2SO4 is it is ionized, it forms proton and HSO4 ion. So proton combines with it and forms an oxonium ion. I am writing over here CH2, CH3, oxygen here, here. This is an oxonium ion, a positive sign, oxonium. Now what actually happens is this oxonium ion in the second step reacts with a nucleophile. What is that nucleophile? I take C2H5OH, ethyl alcohol, another ethyl alcohol molecule, and what actually happens is that ethyl alcohol, that ethyl alcohol will it will basically act as electrophile because of it will be partially electropositive due to which it will act as electrophile. So the alpha carbon of ethyl alcohol, it will react with it and replace this group. It will replace this group. It will replace this group, keep it away, and it will instead come and take its place. Right. This is the entire reaction. So this is, let's put it here, write it in another step. So over here CH3, CH2, CH3, and there is one more thing left. This is oxygen, right? And this is like oxygen, and then we have hydrogen over here, right? And then this what actually happens is, let me just expand this structure. I'm opening this structure, so this is the structure actually. CH3, CH2, OH. What actually happens is the OH, the carbon to oxygen bond is broken. Due to the breakage of the carbon to oxygen bond, this CH2 CH3 becomes electrophile, and the alpha carbon attaches with the oxygen, due to which it forms this structure. This structure CH2 CH3. This is CH3 CH. So this is a structure form. Now this is also an oxoniamine, but this oxoniamine contains two ethyl groups. And what actually happens is, uh, what actually happens is, what actually happens is that the proton which is taken away, this proton combines with this OH group. The proton combines with the OH group, due to which it forms a water molecule. Now, this is the second step. And the third step, what actually happens in the third step is that in the third step, this proton, it will be dissociated and the proton will be given away, due to which it will form an ether, a diethyl ether, a diethyl ether. There is again a mistake. A diethyl ether. CH3. Diethyl ether, and there is uh, the proton and H2O. Now what actually the proton will do is, the proton will combine with H2O and it will form a hydronium ion, while rest diethyl ether would be given away. So this proton again, it will go in equilibrium with the HSO4 ion, which was created initially to produce a proton, and that in that way it would be forming H2SO4 and H2. So this is how the entire reaction goes on for dehydration. But if we talk about other mechanisms, in other reactions the step is pretty simpler. We have number one, oxonium formation, and then oxonium is attacked by nucleophile, due to which this reaction happens. Now let's just move on to another part, which is Williamson synthesis. Williamson synthesis first involves the formation of an alkoxide ion. For example, when I react alcohol with sodium, it will produce an sodium alkoxide ion, and that sodium alkoxide further reacts with an alkyl halide to produce an ether. And then we have the reaction of this mechanism is very important, known as Williamson synthesis. Another mechanism is through the reaction of alkyl halide with silver oxide. When alkyl halides react with silver oxide, with dry silver oxide, it is going to produce ether and silver halide. Now we have some reactions. We just talk about the reaction. The first most important reaction which we are going to have is reaction with hydrogen iodide. Bromine is ether is very unreactive, due to which it does not undergo many reactions with many different compounds, but it undergoes reaction with some of the reactive compounds. For example, when it reacts with hydrogen iodide, it's going to produce oxonium ion at first and a nucleophile. Then that nucleophile attacks over the oxonium ion to form the alcohol and alkyl halide. This reaction is only capable of being done with hydrogen iodide only. If we are going to perform the same reaction with hydrogen bromide, then it's not going to give us alkyl halide and alcohol. Rather, hydrogen bromide would react with ether to form an oxonium ion, and the reaction will stop there. The oxonium ion will be formed and the reaction will be stopped there. There will be no formation of alcohol and alkyl halide. And then we have an important reaction, which is the reaction of reaction of ether with phosphorus pentachloride. Phosphorus pentachloride is reacted with ether, is going to produce alkyl halide. This phosphorus pentachloride is supposed to be hot. It's hot phosphorus pentachloride. And then we have another reaction where we have an acid base reaction. Basically, the oxygen present in the ether has two lone pairs, due to which the oxygen makes ether a Lewis base. And because of its basicity, it is basically a Lewis base, and because of its basicity, it's a weak base. A weak base. Now, this weak base, whenever reacts with a very strong acid like H2SO4, concentrated H2SO4, concentrated HCl, it is going to produce a very unstable ion named as oxonium ion. Oxonium salt. This oxonium salt is unstable and it can decompose back into ether and acid when it is dissolved in water, right? And this is an acidic salt actually. This is an acidic salt. Now let's just move on to some of its uses. Uses are already discussed. It is used as a solvent for very different reactions and it is used as an anesthesia. So these are some of the uses, and that's all about this video. Hopefully we'll meet again in another video.